Whatever you are going to give the input, it will be giving you as output. What are all the types of functions? Here I have taken the polynomial. Polynomial means it will be many, n terms. Correct na? Some terms will be there. Any algebraic equation which will be involving the powers of x as well as the addition, subtraction, multiplication, division are going to be known as the algebraic functions. Where this calculus will be used, ma'am? This calculus divided into two. One is differentiation, another one is integration. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics Faculty, Vidhyaashram, Temple of Excellence, Mysore. In this session, we are going to talk about what do you mean by the functions. Where the functions are used, ma'am? These functions are used for mapping. Whenever you are going to give the input, you are going to get the something as output. Correct na? We are going to use it, the functions. Now let us move on to what do you mean by the function. Function is nothing but it is a relation. Why? Because here between the set A, that means set of inputs, and set of permissible output. Whatever you are going to give the input, it will be giving you as output. Suppose if I am going to take it as let y is equals to x plus 1 and then x belongs to integers. So I am going to give the input as let x is equals to 1 because natural numbers will start from 1. Natural number is nothing but n. So you are going to get the output as y is equals to 1 plus 1 is nothing but 2. So this is an input and this is an output. That's what? The permissible output with the property that each input is related to exactly only one output. Each input is exactly as one output. And let A and B be two non-empty sets. I am going to take it as let A and B be two non-empty sets. These are all two non-empty sets mapping from A to B. F is a mapping from A to B will be a function only when every element of set A has one and only one image in set B. This is set A elements is A, B, C and set B elements are 1, 2, 3. Only one image you are going to have it as. Such relation is going to be known as the function. Whatever you are going to give the input, you are going to get as something output. Okay, that is going to be known as the function. So next we'll be moving on to the condition for a function. What we need to have a condition. The set A and B should be non-empty. Okay, non-empty means there must be any one element present. Okay, and in a function particularly input is given to get a particular output. Okay, so a function f from A to B, this is how we are going to denote. F from A to B denotes the f is a function from A to B where A is said to be a domain and B is said to be a codomain. Here I have taken example. You can see this is going to be known as the domain set. Okay, and this is going to be known as the codomain set. Codomain set. Understood? So next we'll be moving on to the representation of a function. How we are going to represent? We are going to represent as f of x. F of x is equal to, this an example I have taken, x cube. You can take it as any quadratic equation, any cubic equation, logarithmic equation, exponential equation. Like this we are going to denote the function f of x. Okay. So it is said to be f of x, you can read it as f of x, the bracket, f of x, okay. So is equal to x cube. The functions can also be represented by like g of y or t of y or t of z, etc. Like that you can represent the functions. Next we'll be moving on to types of functions. What are all the types of functions? Here I have taken the polynomial. Polynomial means it will be many, n terms. Correct na? Some terms will be there. So real valued function f from P to P I have taken. This is a mapping. Okay. Mapping defined by y is equal to f of a such that h0 plus h1a plus h1 you can take it as h2a square plus etc. plus hn a power n. This is called the polynomial equation. Are you getting? Where these h0, h1a, h1a n power n is belongs to p and n belongs to what? The natural number. Natural number will start from 1, and for each a belongs to p, for each a belongs to some p is called the polynomial function, where here n is nothing but a non-negative integer, that means the natural number. The degree of the polynomial function is the highest power in the expression. The degree of the polynomial is the highest power in the expression you are going to have it as. Otherwise, we can also write the function as like this: a n x power n plus a n minus x power n minus 1 plus etc. a1 x power n a naught, where a naught, a1, a2, this one, a naught, a1, a2, etc. an belongs to what? The real numbers. You can take it as, okay, where x power n is nothing but the variable. Polynomial function as linear function. Here I have taken the degree is 0, it is called as the constant. If the degree is 0, it is a constant function, and if the degree is 1, it is called the linear function. For example, b is equal to a plus 1. You can observe degree is 1 here. Next, you are going to have the polynomial function is a quadratic degree, means it will be a 2. That means you can take the example of ax squared plus bx plus c is equal to 0, where degree is nothing but 2. And the polynomial function is cubic, means you can take it as what? X cube plus 3x squared plus 2x plus 1 equal to 0. This is a cubic equation of degree 3. Okay, these are all the examples of the what? The linear constant degree 1 and degree 2, degree 3, which will come under polynomial functions. Next, we'll be moving on to what do you mean by the linear function. All functions in the form of which form? Ax plus b is going to be known as the linear function. Okay, where a and b belongs to where? The set of all real numbers. Set of all real numbers. Real numbers means what? Which include fractions, decimal point, integers, that are going to be known as real numbers. And a should not be equal to 0. If a equal to 0, it will not exist only b. B is a constant term. So a should not be equal to 0 are called as a linear function. The graph will be a straight line of the linear function. Correct now? Either like this or like this. Any straight line you can have it as. In other words, a linear polynomial function is a first degree polynomial where the input needs to be multiplied by m added to c. Correct now? That means y is equal to here mx plus c. Okay, I have taken example of 2x plus 1 where m is equals to 2 here, and at x is equals to 1, you are going to get f of 1 equal to 3. I told you already, for giving an input, you are going to get something as output. Here I have taken x equal to 1 and f of 1 is nothing but 3. Okay, that is a linear function you can have. Next, we'll be moving on to quadratic function. Quadratic function or the function in the form of ax squared plus bx plus c. This is going to be known as the quadratic, okay, equation, where a, b, c belongs to what? Real number, and a must not be equal to 0. This is going to be known as the quadratic and will be known as the quadratic function. The graph will be parabolic. Here I have taken, this is a parabola where y is equal to x squared or y f of x is equal to x squared. So next we'll be moving on to the rational function. The rational function which will be in the form of p by q. This is a rational form. What is a function? Function means in the form of f of x by g of x or f of a by g of a. Here I have taken where f of a and g of a are the polynomial function. Polynomial means it can be what? The quadratic equation or cubic equation in the numerator as well as in the denominator is defined and in a domain where g of a must not be equal to 0. It defined in the denominator domain. It must be not equal to some values here. So therefore, this is going to be a rational polynomial or a rational function. Okay, next we'll be moving on to algebraic function. The function that consists of finite number of terms. Are you getting? This is important. Involving powers and roots of independent variable x. powers and roots of independent variable x, and fundamental operations such as addition, subtraction. See, you can observe multiplication and division is known as the algebraic equation. Any algebraic equation which will be involving the powers of x as well as the addition, subtraction, multiplication, division are going to be known as the algebraic functions. So this is a simple example. I have taken algebraic function where f of x, function of x equal to 5x cube minus 2x squared plus 3x plus c, which is a cubic equation. Okay. Next we'll be having cubic function. So here a cubic polynomial function is a polynomial of a degree what? 3. And it will be having what? F of x equal to ax cube plus bx squared plus cx plus d, and is not equal to, which is not equal to 0? A is not equal to 0. This is important. A should not be equal to 0. This is called the cubic function. Okay. Next we'll be moving on to very important, the calculus part. Where this calculus will be used, ma'am? This calculus divided into two. One is differentiation, another one is integration. What, ma'am? Where is differentiation is used? Differentiation is used in, now whatever you are facing the pandemic year, the corona model, you are going to use the differential calculus. Okay, this is very, very important, calculus part. Okay, here calculus means it is a branch of mathematics that deals with the continuous change. Why I have taken continuous change? As I told you, you can have CR model. I told you continuous change means this year the corona patients will be more, but next year if you compare, it may be less or more also. The change, the variable change, you are going to have it as, that is nothing but it will be a branch of the calculus. Calculus is also infinitesimal. Infinitesimal means you are going to have integration, that is infinitesimal. Okay. Boundary is nothing but the infinitesimal you are going to have. Calculus or the calculus of the infinitesimal you are going to have it as. Okay, boundary. So the meaning of classical calculus is a study of continuous change in the function. As I told you, study of the continuous change you are going to have it as I told in the corona patients will be more this year or less in the next year. Correct. Now most of these quantities are the functions of the time, such as velocity is equal to change in the distance with respect to time. Correct. Now will be is equal to d divided by time you are going to have it as. So the two major concepts you are going to study, one is derivatives, another one is integrals, and the integration or the derivatives. Next we'll be moving on to what is a definition. Definition means it is a branch of a mathematics developed by whom? Newton and Leibniz. These are all the two persons who have introduced the calculus part. Okay, and deals with the study of rate of change. Rate of change. Calculus maths is generally used for mathematical models to obtain the optimal solutions. Okay, to compare the values, you are going to have it as this calculus, and it helps to understand the changes between the values which are related by a function. And calculus math mainly focused on some important topics such as differentiation, integration, limits, function. All these will be coming under the calculus part. Okay, next we'll be moving on to calculus means a part of maths that deals with the properties of derivatives and the integrals. This is important, of the quantities such as area, volume, velocity, acceleration, etc. by process initially dependent on the summation of infinitesimal differences. It helps to determine the changes between the values that are related to the function. As I told you, it will be helping in the changes of the function with respect to other function, change in the variable. Next we'll be moving on to basic calculus is the study of differentiation and then integration. Study of basic, both the process of differentiation and then integration. Both concepts are based on the idea of the limits. This is very important. And the functions, some concept like continuity, exponential, foundation of advanced calculus. Basic calculus explains about two different types of calculus called the differential calculus and then integral calculus. This is very important, okay? Differential calculus helps to find the rate of change of quantity, okay? And whereas integral calculus helps to find the when the rate of change is known, okay? Both it was developed by Newton and the Leibniz. Next, we'll be moving on to the differential calculus. Differential calculus is concerned with what? The problems of finding the rate of change of the function, which is nothing but dy by dx, rate of change of function. So, and then to get the optimal solution, derivatives are used to find the maximum and the minimum values of the function here. Maximum and minimum value. What is the maximum value of the function at x equal to some point? What are all the minimum values you are going to have it as? What are the maximum suspectants in corona? Who are infected more? Who are infected less? To find all that, we are going to use this differential also, okay? Next, we'll be moving on to what? What is that? Integration. Integration is a reciprocal of the differentiation. Ulta of the differentiation is nothing but the integration. You are going to have it as differentiation can be understood as dividing a part into many small parts. You are going to, suppose if you are having, this is an area you are going to calculate, okay? I want to calculate the area from A to B, means the differentiation is divided into small part, then you are going to calculate the whole area, okay? So that's what, divided into small part in many parts. Integration can be set as a collection of small parts, collection from A to B. Integration is a symbol you are going to have from A to B, the whole area you can collect. Form, it is generally used for a calculating areas. As I told you, for calculating areas it will be useful. And a definite integral has a specific boundary within which function. That means this is an indefinite integral without the boundary. This is a definite integral A to B, where A is the lower limit and B is the upper limit. You are going to have it as, okay? The integration is divided into two parts. One is definite integral, another one is indefinite integral, okay? Next, we'll be moving on to what do you mean by indefinite. Indefinite integral does not have a specific boundary. That means, as I told you, it will be not having a specific boundary. That is, no upper limit and the no lower limit will be defined. Thus, integration is always accompanied by a constant value. Any constant value it will be accompanied. I'll be telling you in the calculus part when it comes to part of the integration, okay? So next will be applications, where we are going to use this one. It helps to analyze the system to find optimal solution to predict the future. In real life, where and all we are going to use, play a major role in either it is related to solve the area of complicated shapes, okay? Safety, area of the complicated shapes means they are going to give this area to calculate. How you are going to calculate? If it is circle, you can have area will be equal to pi r square. If you given like this the curve, how you are going to calculate? It will be useful by using the integration. We are going to calculate this area, okay? Whole area. Next, you are going to have it as safety of the vehicles also will be using this integral calculus, and evaluating the survey of data for business planning. Survey you are going to do by integral calculus only. Then credit card payment records, right? And then you are going to have finding the changing condition of the system which affect us. That means changing in the environment. This here it may be like we are going to calculate change in the environment with respect to other. One dependent on other variable. It is nothing but the differentiation. Integration means the calculating part you are going to have it. Survey you are going to have it as. Next we'll be moving on to the applications as like the physician, economics, biologist, architects, medical experts, see, statistician is often used by them. For example, architects and engineers use the concept of calculus to determine the size and the shape of the curves, okay? Size and the shape of the curves to design what? To design the bridge of that. And roads and tunnels. See, here and all we are going to use the calculus. In calculus, some of the concepts are beautifully modeled, such as birth and death rate. See, birth and death rate, radioactivity decay, And then reaction rate, heat and light motion, electricity, all these are going to use this integral calculus. Our calculus part will be used there. Understood? Thank you, dear student. I think this session was good where we are going to use the calculus part. Okay, thank you.